Continuing now with the second part of technology and utopia, we're going to look at some other examples of where new ideas about social constructs, cities of the next century, could be realized through technological innovation. The first group we'll look at is metabolism. The metabolist movement was started by a group of Japanese architects and city planners in 1959. It can be defined as a radical Japanese avant-garde movement, and it pursued the merging and recycling of architecture styles within an Asian context. The movement was very successful, peaking when its members received praise for the Takara Castilian Botillion at the Osaka World Expo in 1970. The group was dismantled shortly thereafter, though many of its practitioners received individual acclaim for their projects. The categories that the group envisioned for the future of cities around the world are large-scale, flexible, and extendable structures that facilitate an organic growth process. One particular practitioner, a key member of the group, is Kikutaki. For more than half a century, this visionary architect pursued metabolic architecture, embracing forces of renewal, recycling, and transformation. Following the debut of his Sky House and Marine City at the 1959 Siam Conference in Otterloo in the Netherlands, Kikutaki became a leading voice of metabolism. His work was presented on another important international stage at the New York Museum of Modern Art's 1960 Visionary Architecture exhibition. Yet another example of MoMA helping to form taste and disseminate architectural ideas. More recently, Rem Koolhaas has revived within contemporary discourse the metabolist cause of, quote, immense optimism, an ambitious vision of accelerated urbanism and advanced technology existing in parallel with an untainted nature, unquote, in Koolhaas's book, Project Japan. For Kikutaki, such transformative architecture drew on the centuries-old tradition of wooden structures in Japan to rebuild a nation ravaged by war and natural disasters, and then continuously evolved to address societal and technological changes up through the present. The metabolist movement was started, as I said, by a group of Japanese architects and planners, and their goal was to create technologically based cities and structures that would use modular systems and recycled materials to minimize the impact on the environment, but also to extend the flexibility of the structure into the future. The most famous metabolist projects are the Floating City in the Sea, Kikutaki's Marine City, Tower City, the Ocean City, the Wall City, the Agricultural City, the Helix City, the Capsule City. So clearly it is an urban-based architecture. The personal home of Japanese architect Kikutaki is an interesting monument to his architectural beliefs. As a member of the metabolist, Kikutaki laid the foundation for an architecture able to intrinsically provide its own rules for growth. So architecture for architecture. And for new models of cities able to develop over new physical grounds. His Sky House is an elevated single volume that literally embodies both these key principles on a domestic scale. So let's look at this a little bit. The house consists of a single 10 by 10 meter concrete slab raised up on a 4.5 meter high piers located on the central axis on each side in order to free the corners. So you can see this quite well in the image and in the drawings as well. The piers also support the concrete roof. The architect's refusal of functionalism is materialized in an open, flexible floor plan with a central living space and service areas on the sides, which recalls traditional Japanese interior. All around this single space runs a continuous balcony. Kikutake always referred to his own biography, which crosses the history of Japan, to explain his personal elaboration of metabolist principles. He was the son of a wealthy family of landlords, and at 17, when the war ended and his family was suddenly land poor after post-war reforms. Forced to reconsider his new situation, joined the metabolists, and this is when they started to develop a design attitude that addressed the need for buildings to adapt to the mutability of things. Kikutaki's Sky House applies this principle on the small scale, addressing the changeability inherent in a single family. The first addition to the main volume was the children's room, a small space plugged under the floor, which was removed when the children moved away. During more than 50 years, several changes were made to the Sky House. Some improved the building following its own intrinsic logic, and some altered the house's nature. Here is an Ocean City project by Noriaki Kurokawa. Again, you'll notice the modular elements, in this case, that extend out into the water from the land, sort of anchored in the land. Another project by Kurokawa is the Nagaken Capsule Tower in Tokyo. And here's an example of the Metabolist project that was actually built. So in 1958, Kurokawa predicted a transition from the age of the machine to the age of life. And in his writing and work, Kurokawa has continually utilized such keywords as life principles. And as part of metabolism, he refers to the idea of metabolizing and recycling, ecology, sustainability, symbiosis, ambiguity, in order to call for new styles to be implemented for and by society. In his own work, Kurokawa focused on the creation of eco-friendly and sustainable architectural projects. So in this capsule tower, there is a primary structural element onto which these different apartment capsules are affixed. And the goal was that these could be removed and updated or added onto, and that it had this mutability, this flexibility that would meet future needs while serving current needs. A close-up of these different modules. So you'll notice here in this particular cutaway graphic that the capsules were intended to be replaced every 27 years. And the core itself was designed to last 100 years. Unfortunately, while the goal was to have all the capsules be removable, the tower's design ultimately meant that only the top ones could be removed. So sort of a top-down effort was needed in order to replace all of the capsules. And here are some images from within some of these capsules. You'll notice all the built-ins here. For those of you that follow some of the small house proposals of recent years, you should see some similarities here. A lot of built-ins, a lot of movable panels and elements that shift from one programmatic function to another within the domestic sphere. So in the first part of our Technology and Utopia lecture, we looked at examples of groups like the independent group and archigram, and here we've looked at the metabolists. Now we're going to move on to some other work, projects that were built, and where the designers continue to be active in 21st century design, Let's see where they started in the 20th. So Renzo Piano and Richard Rogers built the Centre Pompidou in Paris. This was meant to be a media center, multifunctional art museum, theater production, and the goal was to have the building reflect and sort of animate its many programs. In order to free up the floor plans inside, they created an exoskeleton. And as we've discussed before, on the exoskeleton we also have all of the services. So pipes were all on the outside. It's like having the guts of the building turned inside out. So when Piano and Rogers won the anonymous design competition for the Pompidou, no one in the jury knew who they were. But by the time they publicly presented the design, they were approaching infamy. Many people really hated this project. The French press and design public hated it. And the police had to remove one woman who shouted down Piano and Rogers' ultramodern design. By the time the building was completed in 1977, it was called, even in publications such as the New York Times, the Beaubourg Folly. Ultimately, however, this very unusual structure ended up being vindicated. Paris fell in love with this violent break from architectural history, and, very importantly, they fell in love with the expansive cultural program that took place within this funny skeletal building. Since its completion, the Pompidou has become one of the most visited museums in Paris, and with an open courtyard in front of it, is one of the most vibrant public spaces in the city. We're going to look quickly now at a few other examples of buildings by Piano and Rogers that they created since this early 70s structure. Rogers went on to become well known for his high-tech designs. This is the Lloyd's building in London, completed in the mid-80s, and this is what he says about it. Buildings are not idiosyncratic private institutions. They give public performances both to the user and the passerby. Thus, the architect's responsibility must go beyond the client's program and into the broader public realm. Though the client's program offers the architect a point of departure, it must be questioned, as the architectural solution lies in the complex and often contradictory interpretation of the needs of the individual, the institution, the place, and history. Here you can see the legacy of some of the other utopian projects that we've studied. The sort of modular approach to the exterior skin, the exoskeleton, the service piping, which is now on the outside, and the new use of newer structural technologies to make it all possible. You'll also notice, if you look at the drawing, the integrated cranes, which were part of the final design. The key to this changing juxtaposition of parts is the legibility of the role of each technological component. Another project by Rogers, quite recent, is the Millennium Dome, which was designed and built between 1996 and 1999 to house the Millennium Experience exhibition. The idea was the outcome of an interaction between designers, Imagineers, and the architects, specifically Rogers. It was then taken up by the engineers at Buro Happold, who developed the concept of the tension fabric and cable roof. The structure has now become the icon for the Millennium celebrations in London. The innovative structural concept for the roof of the Millennium Dome is quite simple in concept. Arranged radially over the surface are 72 tension steel stringer cables in pairs of 32 mm diameter steel spiral strands. The stringers are supported at radial spacing between 25 and 30 meters by an arrangement of upper hanger and lower tie-down cables set out around the 1,200-meter high primary steelwork masts. Circumferential cables keep the stringers on their radial lines. A fiberglass fabric was used as cladding. The tension cables are straight and the fabric is basically flat. They both carry the loads by deflection, accompanied by an increase of tension. This concept is simple, but there are dangers associated with the deflections, particularly that of ponding caused by snow or heavy rain. So Rogers has gone from the Pompidou Center to a series, and we could look at many more, a series of very technologically focused projects that we refer to as high-tech architecture. Piano has moved in quite a different direction. In particular, he is known for his museum designs, and we'll look at a couple of these here. The Menil Collection in Houston was his first American project. This is quite a modest neighborhood museum, and it set a new precedent in museum architecture and propelled Piano into his current status as one of the world's most trusted designers of cultural buildings. Piano, specifically in this building, was interested in technological humanism. And he wanted to create a transcendent space for the viewing of art that places the collection and its presentation in perfectly realized natural light. So lighting is the key driver for Piano in many of these buildings. And he wants the architecture to be supportive, so in many cases subservient to the art that is on display. Piano refers to this project and the design details as sculpting light. When completed, the Menil Collection was immediately hailed as a triumph. In the New York Times, Paul Goldberger called it, quote, one of the most pleasing buildings built in our time for the viewing of art, unquote. In many ways, the Menil Collection represents an evolution from the Pompidou, not a break from it. Neither museum matches traditional visions of what museums are supposed to look like. The Pompidou makes obvious allusions to heavy industry, while the Menil softens its edges a bit, calling to mind a well-designed shipping warehouse for a smart startup. The all-encompassing mechanized exterior of the Pompidou is toned down and focused here in this museum. In Houston, glass ceilings allow light to reach a series of custom-engineered concrete and iron leaves present inside and outside of the museum that channel the sun into the galleries. You can see these in this section and also in the photograph in the top on the outside and in the bottom on the inside. 300 such thin, curving sheets offer a sculptural, idiosyncratic sense of handicraftness to the otherwise spare and minimalist white-walled museum. Their presence and visibility from the gallery interiors make their channeling of light a more intimate experience. As Piano said at his Pritzker Architecture Prize acceptance speech, quote, light is as much a part of the composition as the shapes and volumes of the building, unquote. Look quickly at a couple of Piano's other buildings. This is the Kansai Airport. It's located on a specially built island in the Bay of Osaka in Japan. The terminal is 1.7 kilometers long, has 42 boarding gates, and can handle approximately 100,000 passengers a day. Its long and light structure was designed to withstand the violent earthquakes that often affect this particular area of Japan. So this is really seismic design at its finest and most elegant. Piano also designed a new headquarters for the New York Times, This was through an invited competition in 2000. This particular project really opens up a neglected corner of Manhattan opposite the Port Authority. And the building ends up being a 52-story structure. And the key themes for the architectural partie were those of permeability and transparency. And what the piano building workshop goal was here was to express the intrinsic link between the newspaper and the city. So far in this high-tech section, we focused on the work of Renzo Piano and Richard Rogers, emerging out of their shared Pompidou design. But there are other well-known architects also working in this medium. One of those is Norman Foster. And here we see the Renault Distribution Center in Swindon in the United Kingdom. And what you'll notice is that this is a suspended roof structure. In the section, you get a sense of the stays and the cables and how this structure comes together. The benefit of this kind of design is that it opens up space underneath. It's usable for exhibitions, displays, local events, as well as anything that Renault might need to do in terms of its distribution. The lightness of the structure, the fact that it can be extended in theory infinitely, all of this speaks to some of the ideas that we saw with Archigram and the Metabolist. Yet here we see it realized in a very high-tech manner using the latest in structural technologies. Norman Foster is also well known for his Hong Kong and Shanghai Bank, which at one time was the tallest structure in the world. You could see on the exterior of the skyscraper the lateral cross bracing, and on the interior this very high atrium allowing light to pour into the building from the sides and the top of the structure. Foster has become known for his skyscraper design and for their original and image-focused facades. So this is the Swiss Re Tower in London. And a detail of this, you can see the diamond cross bracing, the structural element that covers the entire facade. Recently I visited the British Museum in London and was struck by the great court roof that was built. So prior to this Norman Foster design, the court was open, but now it has been covered by this very delicate, very successful roof, glass and steel, very light, does not take away from the existing architecture, yet manages to create an open sculptural courtyard that is now protected from the elements. And here we have a bird's eye view of that and of the London skyline around the British Museum. Other architects working within this high-tech area include designers such as Jean Nouvel. He has a very eclectic career, and so many of his works are not like this at all. But the Institut du Monde Arabe in Paris is a very interesting example of maybe almost biomimicry, where he creates the facade in glass and steel. It's very technologically focused in terms of its material and aesthetic. But the idea behind it is each one of these different panels would actually work like an oculus, so that as the intensity of the sun increased on the facade, the lens would close, allowing less solar radiation, less light to enter into the interior of the library. So as you're in the space, you can hear the little machines as they move and open and close, allowing more or less light into the primary reading room. Greg Lynn's embryological house, 1997-2001, is a really wonderful, groundbreaking early work of digitally created theoretical architecture. The dynamic forms of the house comprise flowing and vector-based surfaces, sometimes referred to as blob architecture, made possible through animation software. So the 1990s and on, and certainly into the 21st century, software and computer-aided design tools have really radically altered the field and discipline of architecture. In this example, Lynn rethinks the notion of the manufactured house, moving from the modernist idea of a form based on modules to a form based on potentially unlimited iterations derived from a basic form, or what he refers to as a primitive form. His goal is to design and manufacture houses that exhibit variety based on shared regulating principles, a, quote, mass customization, unquote. To allow the mass production of individually unique products, Lynn expects the new capabilities of computer-aided design and computer numerically controlled manufacturing to support this kind of design process. Physical models for the embryological house were produced using prototyping technology in order to test the design's compatibility with available manufacturing technology. The materiality of his models formed an important part of the creative process. For example, Lynn deliberately exposed the means of manufacture by allowing the computer-controlled tools to leave their marks on the model's surfaces. Lynn set a number of goals for this conceptual work. He wanted to rethink the idea of house typology beyond the modernist kit of parts. He wanted to consider an organic, flexible, genetic, generic prototype from which an infinite number of iterations could be generated. He also wanted to extend the interplay of generic and variation implied in this rethinking to notions of product branding and the satisfaction of individual desire through consumer-specific, unique versions of the product. And finally, he wanted to push the capabilities of existing automated manufacturing technologies for the production of non-standard architectural forms. The use of multiple software applications to develop the work's forms is inherent to Lynn's creative process. So coming out of these ideas, computer-aided design, blob, sort of plastic metamorphosizing structures, we're going to quickly flip through a few examples of projects built right at the end of the 20th century that speak to the application of computer-aided design and modeling softwares in their creation. Peter Cook, yes, the same Peter Cook, and Colin Fournier designed the Kunsthaus Graz in Austria. You'll notice the use of the skylights that emerge from the blob-like form. Future Systems designed what is referred to as Blobs, which is the Selfridges store in Birmingham in the UK. The skin of this particular building, we'll zoom in here a bit, you can see there's the inside of the store. It's made of a repeating pattern that coats the skin, not unlike a skin, say, of the scales of a reptile, for example. And so on that note, let's end. The 20th century starts with a reconsideration of what the future means and what it means to be modern, and ends with the promises of new technology through computer-aided design. And in between, there are 2 world wars and countless other influences that tested and pushed the boundaries of what architecture could do and should do.